With that, we're going to move to our first presentation, Hans Kandel. And Hans is a plant science specialist, extension specialist from NDSU, and I'll let you do the rest of the introduction.
Good afternoon. I'm an agronomist, so I'm going to first kick it off here, talking a little bit about agronomy, why we are looking at tile drainage and why there are some effects on the crop production. And the easiest for me to kind of give you an understanding about the effects of tile draining is just by a simple demonstration. I know we have a lot of people here, but I will try to kind of talk through it, and also for those that are a little bit closer can see. I've got a little bucket here which is full of water. And in the bucket I have a sponge, and the sponge is under the water, and therefore it is completely saturated. So today we're talking about water management. And one of the things that we want to avoid is saturated conditions for plant growth. So if the sponge is under the water, it is saturated. If I just take it out of the water, you can see water is dripping out of the sponge. So what is happening, there is gravitation pulls the water out. So what we are doing is, by pulling the water out of the sponge, we're actually pulling air into the sponge. So this sponge is now not leaking anymore. Is there still water in the sponge? Well, most of you were in kindergarten, right? Is there water in the sponge? Yeah. The answer is yes. So there is still water in the sponge, right? So the question that I get asked frequently is that, okay, if you put tile, what is happening is you remove the excess water. So basically the pipe is 3 feet under the ground. We'll see the demonstration. The pipe has holes in it, and if the sponge, in this case, represents the soil, the water goes, by gravity, simplified, goes down into the pipe and can go out. What we create is ideal growing conditions for the plant to grow. Because what do we have here? We have soil, we have nutrients, and we have the right amount of oxygen. If we don't have the oxygen, the plant can't grow. If we don't get the roots to develop, we can't get the plant to establish. Now, many things that we are doing in agriculture is to optimize the growth of the plant. And as you think about a big building, we try to have a big foundation in order to get a big building. The same applies to plant growth. We need to get the root established. So basically what we have created is a condition for plant growth. What happened is the excess water moved out of the pipe. One other thing here in North Dakota is we have seen over the last 10 years that we have more rainfall, and therefore the water table has moved up. In certain parts of North Dakota and northwest Minnesota, we see some salts appearing on the top of the soil. You've probably seen those. If those are salts in the water, those are soluble salts. We are also going to talk about soils in a bit more detail. But I'm talking now from an agronomy standpoint. If we bring salts to the top, how much plant growth do you expect in a salty ground? Not much. You can just look at the areas where we see salt, very little plant growth. So is there a way to remedy, take that salt out, is by reversing the flow of water. We have had water moving up because of the water table bringing the salts. Now, what if you put a pipe down and you let the water go down? Can you reclaim those areas? Yes. Based on our research and based on the things that we have seen, is we can lower the salt content in the soil, and therefore we can reclaim land. So those are two aspects where tile really can make the difference.